Welcome to this peaceful journey through the forest. As you settle into your comfortable position, allow your body to sink deeper into relaxation with each breath you take. Tonight, we'll explore the gentle, fascinating world of forests, not with excitement or urgency, but with the soft, measured pace of nature itself. Each fact, each detail, is designed to calm your mind, slow your thoughts, and guide you into the most restorative sleep. The forest has existed for millions of years, growing, breathing, and resting in cycles as ancient as time itself. Tonight, you're invited to join that rhythm. There's nothing you need to do, nowhere you need to be. Simply listen, breathe, and allow these soothing forest facts to wash over you like a gentle stream flowing over smooth stones. Your only task is to relax more deeply with each passing moment. As we begin, imagine yourself lying on a soft bed of moss in a clearing, surrounded by towering trees. The air is fresh and cool, carrying the subtle scent of pine and earth. Above you, the canopy filters the last light of day into a soft green glow. You are safe here. You are peaceful here. And as you listen to the quiet wisdom of the forest, you'll find yourself drifting naturally into the most peaceful sleep. Let's begin our journey together. Section 1. The Ancient Wisdom of Trees. Trees are among the oldest living beings on our planet, and their presence brings an immediate sense of timelessness and peace. When you stand beneath an ancient tree, you're in the presence of a living organism that has witnessed centuries unfold, weathered countless storms, and yet remains rooted in perfect stillness. This quality of enduring calm is something we can absorb as we learn about these gentle giants. The oldest trees in the world have been growing for thousands of years. There's a bristlecone pine in California that has stood for over 4,800 years, meaning it was already ancient when the pyramids of Egypt were being built. Imagine the patience of such a tree. Year after year, decade after decade, century after century, simply growing, breathing, existing in perfect harmony with its environment. There's no rushing, no anxiety, no urgency. Just slow, steady growth, one ring at a time. Each year, a tree adds another ring to its trunk. These rings are like pages in a diary, recording wet years and dry years, warm seasons and cold ones. The tree doesn't worry about these changes. It simply adapts, grows, and continues. In winter, the tree's growth slows almost to a stop, creating a darker, denser ring. In spring and summer, when water and warmth are abundant, the growth quickens, forming a lighter, wider ring. This patient recording of time reminds us that life moves in cycles, and each season has its purpose. Beneath the surface, where we cannot see, trees are even more remarkable. A tree's root system often mirrors the size of its canopy above ground. For every branch reaching toward the sky, there are roots reaching into the earth, seeking water and minerals, anchoring the tree against winds and storms. These roots spread slowly, carefully, never forcing their way through the soil but finding the spaces between particles, flowing like water through the earth. But roots do more than anchor and nourish. In recent decades, scientists have discovered that trees communicate through their root systems, forming what they call the wood wide web. This network of roots and fungi connects individual trees to one another, allowing them to share nutrients, water, and even chemical signals. A mother tree can recognize her own offspring and will send them extra nutrients through this underground network. When one tree is attacked by insects, it can send warning signals through the root network to neighboring trees, which then begin producing defensive chemicals. This underground cooperation happens slowly, silently, invisibly. The trees don't rush. They don't panic. They simply share what they have, support one another, and exist in a state of continual gentle exchange. Water molecules travel from root to root. Sugars produced by photosynthesis flow through fungal threads thinner than a human hair. Carbon moves through the network like slow electrical signals, carrying information at the unhurried pace of the natural world. The fungi involved in this network are called mycorrhizal fungi, and they form a partnership with tree roots that has existed for over 400 million years. The fungi attach to the tree's roots, extending the tree's reach deep into the soil, accessing water and nutrients the tree couldn't reach alone. In exchange, the tree shares the sugars it produces through photosynthesis. Neither partner could thrive without the other. It's a relationship built on mutual benefit, patience, and the slow accumulation of trust over millions of years of evolution. Think of a single fungal thread called a hypha, so thin that you'd need a microscope to see it. Now imagine that in a single handful of forest soil, there might be several miles of these threads, weaving through the spaces between soil particles, connecting root to root, tree to tree. This vast, invisible network exists beneath every footstep you take in a forest, working silently, tirelessly, without any need for recognition or reward. Ancient trees have witnessed so much, yet they carry their memories in silence. A tree that's 500 years old was a seedling when Leonardo da Vinci was painting the Mona Lisa. It has felt the warmth of countless summers, the cold of countless winters. It has provided shade for animals now extinct, and shelter for birds whose songs have long faded into history. Yet the tree remains, peaceful and present, asking nothing, simply existing in its slow, steady way. The growth of a tree is so gradual that you could watch one for an entire day and see no change. Yet over years, that imperceptible growth creates something magnificent. A giant sequoia can grow to be over 300 feet tall and 30 feet in diameter. Some weigh more than 2 million pounds. Yet they grew from a seed the size of an oat flake. This transformation happened through the accumulation of countless tiny moments of growth, none dramatic, all essential. Trees also rest. During winter in temperate forests, deciduous trees enter a state of dormancy similar to sleep. Their sap thickens, their metabolism slows, and they conserve energy until spring returns. They're not dead, they're resting. And in this rest, they gather the strength they'll need for the burst of growth that comes with warmer weather. Even evergreen trees slow their processes in winter, growing only minimally, conserving resources, waiting patiently for the seasons to turn. There's a particular peace that comes from contemplating the life of a tree. While our lives feel rushed and complex, a tree's existence is elegantly simple. It needs light, water, soil, and air. It grows toward the sun, extends its roots into the earth, and through this simple, patient process, creates oxygen for the world, habitat for countless creatures, beauty for all who see it, and wood that will serve humanity in countless ways. All of this from simply standing still and doing what comes naturally. Consider the life cycle of a leaf. In spring, tiny buds on the branches swell and open, revealing fresh green leaves, soft and vulnerable. Through summer, these leaves work tirelessly, capturing sunlight and converting it into energy through photosynthesis. As autumn approaches, the tree begins to withdraw nutrients from the leaves, saving them for the winter ahead. The green chlorophyll breaks down, revealing the yellows, oranges, and reds that were hidden beneath all along. Finally, the leaf falls, drifting down in a gentle spiral to join the carpet of leaves below, where it will decompose and return its nutrients to the soil, feeding the very tree from which it fell. This cycle continues year after year, each leaf playing its part, each season bringing its changes, all of it unfolding with the measured pace of natural time. There's no rushing the seasons, no hurrying the growth. Everything happens in its own time, according to rhythms far older and wiser than human urgency. The wood of a tree is primarily made of carbon that the tree has pulled from the air. Through photosynthesis, trees take carbon dioxide, a gas, and convert it into solid wood. They're literally building themselves out of air, water, and sunlight. This process is so gradual, so gentle, that we never notice it happening. Yet over decades, this accumulation of captured air becomes a massive trunk, strong enough to support tons of branches and leaves, flexible enough to bend in the strongest winds. When you touch the bark of an old tree, you're touching a boundary between the living world inside and the external environment. Bark protects the tree from fire, insects, disease, and injury. Some bark is smooth, some rough, some peels away in papery layers, some is deeply furrowed. Each type of bark tells a story about the tree's adaptations to its environment. Birch bark is white and papery, helping the tree reflect light and heat in northern climates. Oak bark is thick and rugged, protecting against fire and insect damage. Cork oak bark can be harvested without harming the tree, which simply grows more bark to replace what was taken. The patience of trees is perhaps their most remarkable quality. They cannot move, cannot flee from danger, cannot chase resources. They must work with whatever conditions they find where they germinated. Too much shade? Grow taller slowly year by year. Soil too poor? Extend roots further, deeper, wider, patiently searching for nutrients. Competition from other trees? Adjust your crown shape. Find the gaps in the canopy. Be flexible. Be patient. Everything in a tree's life happens at nature's pace. And yet trees have successfully colonized nearly every land environment on Earth. As you think about these ancient, patient beings, allow yourself to absorb some of their calm. Feel yourself becoming rooted, stable, peaceful. Like a tree, you don't need to rush anywhere. Like a tree, you can simply be, breathing in and out, existing in this present moment, growing imperceptibly toward your own light, in your own time, at your own perfect pace. Section 2. The forest's breathing rhythm. A forest breathes. This isn't poetry, it's biology. During the day, forests inhale carbon dioxide and exhale oxygen through the process of photosynthesis. At night, like all living things, they reverse this process slightly, taking in oxygen and releasing carbon dioxide as they metabolize the sugars they created during daylight. But the daytime production far exceeds the nighttime consumption, meaning forests are net producers of the oxygen we breathe. Every breath you take contains oxygen that was likely produced by a plant, perhaps a tree in a forest far away, or perhaps a tree just outside your window. Photosynthesis is one of the most elegant chemical processes in nature, and it happens in near silence with no moving parts, requiring only light, water, and air. Inside every green leaf are millions of tiny structures called chloroplasts, and inside each chloroplast are even tinier structures where the magic happens. When sunlight strikes a chloroplast, its energy breaks apart water molecules, separating hydrogen from oxygen. The oxygen is released into the air, the very oxygen you're breathing right now as you relax and prepare for sleep. The hydrogen is combined with carbon dioxide from the air to create simple sugars, which the tree uses for energy and growth. This process is happening right now in forests around the world. Even as you lie here preparing for sleep, there are forests in different time zones where the sun is shining, where millions of trees are quietly breathing in carbon dioxide and breathing out oxygen, purifying the air, supporting life, asking nothing in return. It's been happening for hundreds of millions of years, long before humans existed, and it continues with the same gentle, reliable rhythm. The amount of oxygen produced by forests is staggering when you contemplate it. A single large tree can produce enough oxygen in a year to support 2 people. A hectare of forest, about the size of 2 football fields, can absorb as much carbon dioxide in a year as a car produces driving 12,000 miles. But these numbers, impressive as they are, don't capture the quiet constancy of this process. Hour after hour, day after day, season after season, forests breathe, creating the very atmosphere that makes life possible. During spring and summer, when days are long and the sun is strong, photosynthesis happens vigorously. This is when trees do most of their growing, producing new leaves, extending branches, thickening their trunks. You can almost feel the energy of the forest during these months, though it remains peaceful, channeled through natural processes that have been refined over millions of years. Even this vigorous growth is unhurried by human standards. You'd never see a tree grow if you watched it, yet the growth is real and constant. As autumn approaches and days grow shorter, the pace of photosynthesis slows. Deciduous trees begin preparing for winter, gradually shutting down their food production, withdrawing nutrients from their leaves to store in their roots and trunk for the winter ahead. The green chlorophyll that dominated the leaves all summer breaks down, revealing other pigments, carotenoids that show yellows and oranges, and anthocyanins that create reds and purples. These colors were present all along, masked by the overwhelming green of chlorophyll. Now, as the tree rests, its hidden beauty is revealed. This seasonal breathing pattern means that forests in temperate regions have a pulse, a yearly rhythm of activity and rest, growth and dormancy, intake and release. In spring, the forest takes a deep breath in, awakening from winter's sleep. In summer, it breathes deeply and steadily, fully alive and productive. In autumn, it begins to exhale, releasing what it doesn't need, preparing for rest. In winter, its breathing slows to a whisper, conserving energy, waiting patiently for the wheel of seasons to turn once more. Tropical rainforests, by contrast, breathe steadily year-round. With consistent warmth and rainfall, they have no need for dormancy. They produce oxygen constantly, day after day, which is why they're often called the lungs of the earth. The Amazon rainforest alone produces about 6% of Earth's oxygen. Think of this vast green expanse, covering millions of square miles, every tree and plant breathing, every leaf working silently to sustain life, all of it happening without fanfare, without recognition, simply because that's what forests do. The breathing of forests also influences local weather. Through their leaves, trees release water vapor in a process called transpiration. A single large oak tree can transpire up to 40,000 gallons of water per year. This water rises into the atmosphere, where it can form clouds and eventually fall as rain. Forests essentially create their own rain, participating in the water cycle, humidifying the air, cooling their environment. Stand in a forest on a hot day, and you'll feel this cooling effect. It's not just shade, but the gentle release of water vapor from millions of leaves, creating a microclimate that's several degrees cooler than the surrounding area. This transpiration follows a daily rhythm. As the sun rises and heats the leaves, the stomata, tiny pores on the leaf surface, open to allow photosynthesis. As water evaporates through these pores, it creates a pull that draws more water up from the roots, like sucking on a straw. This flow of water from roots to leaves can be surprisingly strong. In a tall tree, water must travel hundreds of feet upward against gravity, yet it does so smoothly, powered only by evaporation and the cohesive properties of water molecules. At night, the stomata close and transpiration slows. The tree conserves water, rests, performs the internal metabolic processes it needs for maintenance and repair. This daily rhythm means that forests have a breathing pattern not just seasonally, but day by day, hour by hour. They breathe with the sun, slowing their respiration in darkness, speeding it up in light, perfectly synchronized with the Earth's rotation. The oxygen released by photosynthesis is a byproduct, something the tree doesn't need and discards. Yet this waste product is essential for nearly all animal life on Earth. We breathe in what trees breathe out. They breathe in what we breathe out. It's a perfect exchange, a symbiosis that connects all life on the planet. When you breathe in deeply, relaxing your body, preparing for sleep, you're participating in this ancient exchange. The oxygen filling your lungs was a gift from a plant, perhaps from a tree, perhaps from algae in the ocean, but certainly from photosynthesis, from the green life that covers our planet. Carbon dioxide levels in Earth's atmosphere fluctuate slightly with the seasons, higher in winter when northern hemisphere forests are dormant, lower in summer when they're actively photosynthesizing. The planet itself breathes, and we can measure this breath from space, watching the concentration of carbon dioxide rise and fall with the seasons. It's a reminder that Earth is not a dead rock but a living system, and forests are among its most vital organs. The rate of photosynthesis responds to light levels with remarkable sensitivity. On a cloudy day, photosynthesis slows. When clouds part and sunlight streams through, it accelerates. This responsiveness happens within minutes, as the molecular machinery inside chloroplasts adjusts to available light. Yet despite this rapid adjustment, there's no sense of urgency or stress. The tree simply does more when it can, less when it can't, accepting conditions as they are, working with what's available. Consider the journey of a single molecule of carbon dioxide. It drifts through the air, perhaps released by your breath right now as you exhale and relax. Travels on air currents, perhaps for miles, perhaps for days. Eventually, it encounters a leaf, enters through a stoma, and finds its way to a chloroplast. There, powered by sunlight, it's combined with hydrogen from water to create a simple sugar. This sugar might be used immediately for energy, or it might be stored, or it might become part of the tree's structure, cellulose in the cell walls, adding to the tree's mass. That carbon atom, which was in your breath, is now part of a tree, possibly for centuries, locked away in wood until the tree dies and decomposes, releasing it back to the cycle. This cycling of elements, carbon, oxygen, nitrogen, hydrogen, is the breathing of the earth itself. Nothing is wasted. Everything is recycled. A carbon atom in your body right now might have been part of a dinosaur millions of years ago, then part of the atmosphere, then part of an ancient tree, then back to the atmosphere when that tree decayed, then into your body through the food you ate. You are made of recycled stardust, atoms that have passed through countless forms, all connected through the patient breathing of forests and oceans and all living things. As you rest here, breathing slowly and deeply, imagine yourself connected to this vast network of breath. Your inhale is the forest's exhale. Your exhale is the forest's inhale. You are not separate from nature but part of it, participating in exchanges that are as old as life itself. With each breath, you're taking in oxygen created by photosynthesis, perhaps today, perhaps months ago. With each exhale, you're releasing carbon dioxide that plants will use to grow. Even in sleep, even in complete rest, you're participating in this global exchange, this planetary breathing. The beauty of this system is its completeness. Nothing is wasted, nothing is outside the cycle. The forest breathes, you breathe, and together you sustain each other. It's been this way for millions of years, and it will continue for millions more. There's a deep peace in contemplating these cycles. They were here before you, they'll be here after you, and while you're here, you're part of them, connected to all life through the simple act of breathing. As your breath slows and deepens with approaching sleep, know that you're mirroring the nighttime rhythm of the forest. Just as the forest's breathing slows at night, so does yours. Just as the forest rests and repairs and prepares for tomorrow, so do you. You are not separate from nature. You are nature, breathing, resting, existing in perfect harmony with the living planet. Section 3. Woodland water cycles. Water moves through a forest in ways both visible and invisible, creating a complex system that sustains all life within it. The journey of water through a forest is a story of patience, persistence, and the gentle power of natural cycles. Understanding this journey can bring a deep sense of peace, as we recognize the reliability and constancy of these natural processes that have sustained life for millions of years. Rain falls on the forest canopy, and immediately, the forest begins to slow it down. Unlike rain falling on bare ground or pavement, rain falling on a forest must navigate through layers of leaves and branches before reaching the soil. This interception by the canopy can reduce the force of raindrops by up to 90%, protecting the soil below from erosion and allowing the water to enter the ground gently, gradually, naturally. Some raindrops land on leaves and remain there, forming perfect beads that reflect the sky. These droplets might evaporate directly back into the atmosphere, never reaching the ground at all. This is called interception loss, and in dense forests, it can account for up to 30% of rainfall. The water simply completes a small cycle, from cloud to leaf to air, without ever touching the ground. There's something peaceful about the completeness of even this small cycle, water following its nature, flowing where it will. Other raindrops coalesce on leaves and branches, growing heavier until they fall to the next layer below. A single raindrop might fall from leaf to leaf to leaf, its journey down taking minutes instead of seconds, slowed by the forest's architecture. This gradual descent means that even in heavy rain, the forest floor receives water gently, consistently, without the erosive force of direct rainfall. Some water runs down the trunks of trees in a process called stem flow. If you've ever touched a tree trunk during or after rain, you might have noticed it's wetter on one side, the side from which the wind drove the rain. This water carries dissolved nutrients from the bark and any organisms living on the trunk, delivering a concentrated solution of nutrients to the soil near the tree's base. It's a small but significant way that trees capture and direct resources to exactly where they're needed. When water finally reaches the forest floor, it encounters another layer of protection: the leaf litter. This spongy mat of decomposing leaves, twigs, and organic matter acts like a giant sponge, absorbing water and releasing it slowly. In a healthy deciduous forest, the leaf litter might be several inches thick, and it can absorb its own weight in water. This absorption prevents runoff, reduces flooding downstream, and ensures that water enters the soil slowly enough to be captured by roots and pore spaces rather than running off the surface. Beneath the leaf litter is the topsoil, dark and rich with organic matter. This layer is alive with billions of organisms: bacteria, fungi, insects, worms, all working to break down organic matter and create the rich, loose soil structure that can hold immense amounts of water. A single gram of forest soil can contain several billion bacteria, and each one plays a role in maintaining the soil's structure and fertility. These organisms need water, but not too much, and the forest's water management system provides exactly what they need. As water seeps deeper, it enters the subsoil, where tree roots reach far and wide. Water molecules move through the soil slowly, pulled by gravity downward, drawn by roots sideways, moving through tiny spaces between soil particles. A water molecule might take days or weeks to travel through just a few feet of soil, its path unpredictable, determined by the microscopic landscape through which it moves. Tree roots absorb this water, pulling it into their vascular system. The water then begins an upward journey through the xylem, hollow tubes made of dead cells, stacked end to end like a microscopic pipeline. In a tall tree, water might rise over 300 feet from root to leaf, pulled upward by the evaporation of water from leaves, a process so steady and reliable that it continues day after day, year after year, for the entire life of the tree. This upward flow of water is called the transpiration stream, and it serves multiple purposes. It brings water to all parts of the tree. It delivers dissolved minerals absorbed by the roots. It provides the raw material for photosynthesis. And it cools the tree as evaporation from leaves releases heat into the atmosphere. A single large tree can transpire hundreds of gallons of water per day during the growing season. Yet this happens so gradually that we never notice it. The water simply disappears into the air, molecule by molecule, joining the atmospheric water vapor that will eventually form clouds and rain again. Streams and rivers in forests are sustained by this slow release of water from the soil. During rain, water enters the soil and moves gradually toward lower elevations, emerging as springs and seeps that feed streams. This gradual release means that forest streams continue flowing long after the rain has stopped. In fact, a healthy forest can sustain stream flow for weeks or even months after significant rainfall, slowly releasing the water it captured, filtering it through soil and root systems, sending it downstream clean and cool. The water in a forest stream has been filtered by the forest itself. As water moved through the soil, particles were filtered out, nutrients were absorbed and released, bacteria and fungi processed organic compounds, and what emerges is typically very clean water. Before modern water treatment, many cities obtained their drinking water directly from forested watersheds, relying on the forest's natural filtration to provide clean water. Some still do. Forest streams are also cooled by shade from the forest canopy and by the input of cool groundwater from springs. This cool water is essential for many aquatic organisms, particularly salmon and trout, which require cold water to survive. A stream flowing through an intact forest might be 10 or even 20 degrees cooler than a stream flowing through an open area in the same climate. This cooling is a service the forest provides simply by being there, by shading the stream, by releasing cool water slowly from the ground. The sound of a stream flowing through a forest is one of nature's most reliably peaceful sounds. The gentle gurgle and rush of water over rocks, the occasional splash, the constant whisper of flow. These sounds have a measurably calming effect on the human nervous system. Studies have shown that the sound of flowing water can reduce stress hormones, lower blood pressure, and promote relaxation. Perhaps this is because our ancestors lived near water sources, or perhaps it's the inherent rhythm and constancy of the sound. But whatever the reason, listening to a stream is universally recognized as peaceful. Waterfalls, too, create their own peaceful presence in forests. The rush of water over a drop, the mist that rises from the pool below, the negative ions generated by falling water, all of these contribute to the special atmosphere around waterfalls. The mist created by waterfalls can travel hundreds of feet on the wind, creating microclimates around the falls that support plants and animals that couldn't survive elsewhere in the forest. Mosses and ferns thrive in this constant humidity, creating hanging gardens on the rocks beside and behind the falls. In winter, in temperate and boreal forests, water takes on yet another form: ice and snow. Snow falling on a forest creates a special kind of silence. The snow muffles sound, absorbing noises that would normally travel through the forest. Under heavy snow, a forest becomes extraordinarily quiet, each branch and twig bearing its burden of snow with patient endurance. The trees rest, the animals rest, and the water itself rests, frozen but not lifeless, waiting for spring's warmth to set it flowing again. The snowpack in a forest melts more slowly than snow in open areas. The shade from trees slows melting, extending the period during which water is released into streams. This slow release prevents flooding and ensures that streams continue flowing well into summer, sustained by snowmelt long after the snow has disappeared. In many mountainous regions, forests act as natural water towers, storing winter precipitation and releasing it gradually through spring and summer when it's most needed downstream. Morning dew is another beautiful manifestation of water in forests. As night cools the air, water vapor condenses on surfaces, leaves, grass, spider webs, creating countless droplets that jewel the forest at dawn. Each drop is a tiny lens, refracting light, creating sparkles and rainbows. The dew represents water that never fell as rain but simply condensed from the humid air, another small cycle within the larger pattern. By mid-morning, the sun will have evaporated this dew, sending it back into the atmosphere to continue its journey. Fog and mist are common in many forests, particularly in coastal and mountain regions. Fog is essentially a cloud touching the ground, and when it moves through a forest, it deposits water on every surface it touches. This fog drip can be a significant source of water in some ecosystems, particularly in places like coastal California, where summer rain is rare but fog is common. Trees capture water from fog more effectively than open ground, and in fog-dependent forests, the trees essentially harvest water from the air, allowing them to survive months without rain. The water cycle in a forest is ultimately a cycle of transformation and return. Water falls as rain, is captured by the canopy, slowed by leaves and litter, absorbed by soil, taken up by roots, transported to leaves, released as vapor, rises into the atmosphere, and eventually falls as rain again. Nothing is lost. Everything is reused. The same water molecules have been cycling through forests for millions of years, each molecule on its own endless journey, following physical laws, responding to temperature and pressure, flowing always to the lowest point, yet always returning to the sky through evaporation. As you rest here, breathing slowly, sinking deeper into relaxation, imagine yourself as part of this water cycle. Your body is more than 60% water. Every cell in your body contains water, and that water is constantly cycling. You take in water when you drink, you release it when you breathe and sweat and use the bathroom, and this water joins the global cycle. The water in your body right now might have been in a cloud yesterday, in a forest stream last week, in the ocean last month, in a dinosaur millions of years ago. You are a temporary vessel for water on its eternal journey, and in this, you are connected to all life, all forests, all rivers and oceans. Let the thought of water's patient cycling bring you peace. Water is never in a hurry, yet it shapes mountains, carves canyons, and sustains all life. It simply flows, following its nature, and in doing so, accomplishes everything necessary. As you drift towards sleep, follow water's example. Flow where you're meant to flow, rest when rest comes naturally, and trust in the ancient patterns that sustain all life. Section 4. The gentle lives of forest creatures. The animals that call the forest home live lives of quiet routine, shaped by the rhythms of day and night, season and weather. These creatures move through the forest with an innate understanding of their place, their needs, their routines. Observing or even just contemplating their lives can bring a sense of peace, as we recognize the simplicity and completeness of lives lived in accordance with natural patterns. As evening falls on the forest and you prepare for sleep, an entirely different community of animals is just waking up. Nocturnal animals have adapted to live in the darkness, and they bring their own gentle energy to the nighttime forest. The great horned owl sits motionless on her perch, her enormous eyes seeing clearly in light levels that would leave us completely blind. She waits patiently, listening, her ear openings asymmetrically placed on her skull to help her pinpoint the location of sounds with extraordinary precision. A mouse rustles in the leaf litter 50 feet away, and the owl hears it, calculates its location in three-dimensional space, and when the moment is right, launches herself into silent flight, her specially adapted feathers muffling any sound that might warn her prey. This hunting is necessary for the owl's survival, but there's no cruelty in it, no malice, no excess. The owl takes what she needs, no more, and in doing so, she plays her role in keeping mouse populations in balance. The mouse, too, plays its role, and in the economy of the forest, every death supports new life. It's a system that has worked for millions of years, each species taking its place, playing its part, the whole greater than the sum of its parts. Deer move through the forest in the early morning and evening, browsing on leaves and twigs, always alert but not fearful. A deer's life is one of constant awareness but not constant stress. They feed, they rest, they groom themselves and each other. They move to new areas when food becomes scarce. A deer can hear a twig snap hundreds of feet away, can detect movement through the trees, can smell a predator from remarkable distances. Yet despite this constant sensory awareness, deer seem peaceful, graceful, unhurried in their movements. In spring, fawns are born, perfectly camouflaged with white spots that mimic dappled sunlight on the forest floor. The doe leaves her fawn hidden in deep grass or under bushes, knowing that its best protection is to remain still and scentless. She returns several times a day to nurse, but otherwise stays away, preventing her scent from leading predators to her baby. The fawn's instinct is to freeze, to remain absolutely motionless, trusting in its camouflage and in its mother's wisdom. This patience, this ability to simply be still and wait, is something we might learn from. Squirrels are among the forest's busiest residents, yet even their busyness has a peaceful quality to it. They gather acorns in autumn, burying them individually throughout the forest, each burial site marked in the squirrel's remarkable spatial memory. They don't find all of these acorns again, and the ones they miss often sprout into oak saplings, making squirrels one of the forest's primary planters of trees. A squirrel doesn't worry about the acorns it forgot. It buried more than enough to see it through winter, and its forgetfulness serves the forest by planting new trees. There's an elegant efficiency in this system, where even forgetfulness serves a purpose. Bears, those powerful symbols of the wild forest, spend much of their time doing surprisingly peaceful activities. They forage for berries, dig for roots, overturn logs looking for insects, fish in streams during salmon runs, and eat enormous quantities of food in preparation for winter. A black bear might need to consume 20,000 calories per day in late summer and autumn, building up the fat reserves it will need to survive winter hibernation. This single-minded focus on eating is not gluttony but preparation, and the bear follows its instincts without question or doubt. Hibernation itself is one of nature's most remarkable adaptations to harsh conditions. As winter approaches and food becomes scarce, bears retreat to dens, often under fallen trees, in caves, or in hollowed-out trees, and enter a state of deep torpor. Their body temperature drops, their heart rate slows from 50 beats per minute to as few as 8. Their breathing becomes shallow and infrequent. They don't eat, drink, urinate, or defecate for months, living entirely off their stored fat. It's a state of profound rest, the ultimate conservation of energy, a patient waiting for spring's return. Female bears give birth during hibernation, usually to 2 or 3 cubs. These cubs are born blind, hairless, and weighing less than a pound, but they're born into the perfect nursery, a warm den with a sleeping mother whose body heat keeps them warm and whose milk provides all the nutrition they need. The mother bear doesn't fully wake during birth or nursing. She does it in her sleep, her body knowing exactly what to do, following patterns established millions of years ago. Songbirds bring a different kind of life to the forest. Their morning chorus begins before dawn, each species singing its own song, together creating a symphony that welcomes the new day. The songs serve practical purposes, defending territory, attracting mates, but to human ears, they're simply beautiful. A thrush's fluting melody, a warbler's rapid trill, a cardinal's clear whistle, each voice distinct, each one perfect in its own way. Birds build their nests with incredible patience and skill, weaving together twigs, grass, moss, lichen, and mud to create secure cradles for their eggs. Some birds, like the Baltimore oriole, weave hanging baskets from plant fibers, creating hammock-like nests that swing from the tips of branches, safe from most predators. Others, like woodpeckers, excavate cavities in dead trees, chiseling out chambers that will serve not only their own needs but, in future years, the needs of other cavity-nesting birds and even mammals like flying squirrels. The robin's nest of mud and grass, the hummingbird's tiny cup decorated with lichens and bound with spider silk, the eagle's massive stick nest used and added to year after year until it weighs hundreds of pounds. Each nest is perfectly adapted to its builder's needs. The bird doesn't have blueprints or instructions. It simply knows what to do, guided by instinct refined over millions of years of evolution. Frogs and salamanders spend much of their time in patient stillness. A frog might sit motionless for hours, waiting for an insect to come within range of its long, sticky tongue. This stillness is not boredom or laziness but efficiency. By remaining still, the frog conserves energy and avoids attracting the attention of predators. When prey does come close enough, the frog strikes with astonishing speed, its tongue shooting out and back in a fraction of a second. But until that moment, perfect stillness, perfect patience. Salamanders, living in the moist leaf litter and under logs, move slowly through their world, hunting for tiny invertebrates, avoiding drying out, finding mates in the spring when they migrate to vernal pools to lay their eggs. Some salamanders live for 20 years or more, moving slowly through the seasons, never in a hurry, simply existing in the cool, damp spaces they call home. Foxes are creatures of remarkable adaptability, equally at home hunting mice in a meadow or raiding a garden for vegetables. In the forest, they den under fallen trees or in abandoned burrows, raising kits that are playful and curious, learning the skills they'll need to survive through play. Fox kits wrestling, pouncing on each other, stalking leaves blown by the wind. All of this play is practice for hunting, but it's also simply joy, the delight of young animals exploring their world. As the kits grow and become independent, they disperse to find their own territories. A young fox might travel 50 miles or more, searching for an unoccupied area where it can establish itself. This dispersal prevents inbreeding and ensures that foxes are spread throughout suitable habitat. The fox doesn't plan this journey. It simply feels the urge to wander and follows it, trusting in its ability to find what it needs. Insects, though often overlooked, are among the forest's most important residents. Ants create massive underground colonies, some containing hundreds of thousands of individuals, all working together with no central planning or command structure. Each ant simply follows simple rules. If you find food, carry it back to the nest. If you encounter a threat, release alarm pheromones. If it's time to build, add to the nest structure. And from these simple individual actions, complex colony behaviors emerge. Beetles living under bark help break down dead wood, creating channels and spaces where fungi and bacteria can enter, accelerating decomposition and returning nutrients to the soil. Butterfly caterpillars feed on leaves, sometimes in such numbers that they can defoliate entire trees. Yet the trees usually survive and grow new leaves. The caterpillars then pupate, transforming in their chrysalises in one of nature's most magical metamorphoses, emerging as adult butterflies who will feed on nectar, pollinate flowers, and eventually lay eggs to continue the cycle. Fireflies light up summer evenings in some forests, each species with its own flashing pattern. Males signaling to females, females responding, courtship conducted in bioluminescent light. The mechanism of firefly light is remarkably efficient, producing almost no heat, unlike incandescent bulbs which waste most of their energy as heat. The light comes from a chemical reaction in the firefly's abdomen, and it can be turned on and off at will, each flash a beacon in the darkness. Spiders are master engineers, weaving webs of silk stronger than steel, strand by strand, following an instinctive pattern that creates perfect geometric structures. An orb weaver starts with a frame, then adds radial threads like the spokes of a wheel, and finally spirals from the outside in, laying down the sticky spiral thread that will trap flying insects. The spider then retires to the center of the web or to a nearby retreat and waits, feeling through the silk for the vibrations that signal trapped prey. The spider's patience is absolute. It might wait days for a meal, but when something does fly into the web, the spider responds immediately, rushing out to wrap the struggling insect in silk before it can escape. But until that moment, simply waiting, conserving energy, trusting that eventually, food will come. It's a lesson in patience, in acceptance of what is, in working with natural rhythms rather than against them. Many animals in the forest migrate seasonally, traveling hundreds or even thousands of miles to follow food sources or suitable climate. Warblers that spent the summer in northern forests fly to Central and South America for the winter, navigating by the stars, the Earth's magnetic field, and landmarks they recognize. They might weigh less than half an ounce, yet they'll fly thousands of miles, crossing oceans and mountains, facing storms and predators, driven by instinct to return to the same winter territories they've used for years. The caribou of the boreal forests undertake some of the longest land migrations on Earth, traveling up to 3,000 miles per year between their calving grounds and their winter range. They move as a herd, thousands of animals flowing across the landscape like a river, each individual part of something larger than itself, protected by numbers, guided by generations of inherited knowledge about where to go and when. Salmon, born in forest streams, swim to the ocean where they spend years feeding and growing, then return to the exact stream where they were born to spawn and die. How they navigate back to their birth stream is still not fully understood. They use the Earth's magnetic field, the position of the sun, the smell of their home stream, but whatever the mechanism, their drive is absolute. They swim upstream against fierce currents, leap up waterfalls, exhaust themselves completely to reach their spawning grounds, and having spawned, they die, their bodies feeding the stream ecosystem and fertilizing the forest around it. This cycle of migration, reproduction, and death enriches the forest. The nutrients from ocean-caught prey, stored in the salmon's body, are delivered to the stream and the surrounding forest when the salmon dies. Bears, eagles, and other predators drag salmon carcasses into the forest, distributing nutrients even further. Trees growing near salmon streams grow faster than trees far from salmon streams, nourished by this annual delivery of ocean nutrients. It's a connection between ocean and forest, mediated by salmon, that has existed for millions of years. As you rest here, preparing for sleep, know that all around the world, in forests in every time zone, these gentle routines are playing out. Nocturnal animals are waking, diurnal animals are finding their roosting spots, owls are hunting, deer are bedding down. Bears are deep in hibernation or, in warmer months, foraging in the darkness. These animals don't worry about tomorrow. They don't regret yesterday. They simply exist in this moment, doing what comes naturally, following patterns established long before humans existed. You can rest in that same way. Let go of tomorrow's concerns. Release yesterday's regrets. Simply be here now, breathing, relaxing, allowing sleep to come in its own time, in its own way. Like the animals of the forest, you are part of natural cycles, and rest is as natural and necessary as waking. Trust in the process. Trust in your body's wisdom. Let yourself sink deeper into the peaceful rhythms of the natural world. Section 5. Forest soil and the hidden world below. Beneath your feet when you walk through a forest, invisible to casual observation, exists an entire world of astonishing complexity and beauty. The soil beneath a healthy forest is not mere dirt. It's a living system, teeming with more organisms than there are humans on Earth, all working together in ways that sustain the forest above and, ultimately, all life on our planet. A single teaspoon of forest soil contains more organisms than there are people on Earth. Billions of bacteria, meters of fungal threads, protozoa, nematodes, mites, springtails, and countless other microscopic creatures, all pursuing their lives in the spaces between soil particles. These organisms break down dead organic matter, cycle nutrients, aerate the soil, fight diseases, and form the very foundation of the forest ecosystem. Without them, there would be no forest. The topmost layer of soil, the part you see when you brush away the leaves, is called the horizon, the organic layer. It's composed primarily of decomposing plant material. Leaves, twigs, bark, fallen fruits, dead insects, animal droppings, and the remains of all organisms that lived and died in the forest. This material might look like it's just lying there inactive, but it's actually being actively transformed by countless organisms, slowly converted from recognizable plant parts into dark, crumbly humus. This decomposition is a slow process, dignified in its thoroughness. A single oak leaf that falls in autumn might take 2 to 3 years to completely decompose in a temperate forest. It doesn't vanish overnight. Instead, it goes through stages. First, it's colonized by fungi and bacteria that begin breaking down the softer parts. Then larger organisms, springtails, mites, millipedes, begin eating the partly decomposed material, breaking it into smaller pieces, passing it through their digestive systems where bacteria continue the breakdown. Eventually, the leaf is reduced to particles so small they become part of the soil itself, indistinguishable from the general organic matter that gives forest soil its dark color and rich smell. Fungi are among the most important decomposers in forests, and they accomplish this work through a network of threads called hyphae, so thin that thousands could fit in the width of a human hair. These threads grow through the soil and into dead wood, leaves, and other organic matter, secreting enzymes that break down complex molecules into simpler compounds the fungi can absorb. Some fungi specialize in breaking down cellulose, others lignin, the tough material that gives wood its strength. Together, they can decompose virtually any organic material, given enough time. The fungal network in a forest is vast beyond imagining. In a typical healthy forest, the top few inches of soil might contain several tons of fungal biomass per acre, more than the weight of all the tree's leaves combined. These fungi form a web connecting plants to each other, facilitating the exchange of nutrients, water, and chemical signals. This network has been called the Wood Wide Web, and it functions similarly to an internet, allowing communication and resource sharing across the forest. Mycorrhizal fungi form partnerships with tree roots, a relationship so ancient and fundamental that most plants cannot survive without it. The fungi colonize the tree's fine roots, extending the root system's reach by orders of magnitude. A mycorrhizal network can have hundreds of times more surface area than the tree's roots alone, allowing the tree to access water and nutrients it could never reach otherwise. In exchange, the tree provides the fungi with sugars produced through photosynthesis. Both partners benefit. Neither can thrive without the other. These mycorrhizal networks can be astonishingly extensive. A single fungal network might connect dozens of trees, extending through acres of forest, essentially creating a superorganism that shares resources across the entire network. A tree with access to water can share it with a tree suffering from drought. A tree receiving more sunlight can share its excess sugars with a tree growing in shade. A dying tree can transfer its nutrients to younger trees, giving them a boost before its own death. This sharing is automatic, built into the system, requiring no conscious decision or intention. The soil structure is created largely by these organisms. As fungal hyphae grow through the soil, they physically bind soil particles together, creating aggregates that give soil its crumbly texture and create the pore spaces that hold air and water. Earthworms, passing soil through their digestive systems, mix organic matter deeply into the mineral soil and create vertical channels that allow water and roots to penetrate deeply. Tree roots, as they grow and then die and decompose, leave channels that make the soil more porous and easier for new roots to colonize. This structure matters enormously for the forest's health. Soil with good structure can absorb and hold large amounts of water, preventing runoff and erosion while storing water for use during dry periods. It allows oxygen to reach deep into the soil where roots and aerobic organisms need it. It provides countless microhabitats for soil organisms, creating the diversity that makes the system resilient to disturbance. Nitrogen, essential for all life, cycles through the soil in forms transformed by bacteria. Some bacteria can take nitrogen gas from the air and convert it into forms plants can use, a process called nitrogen fixation. Others convert ammonium to nitrite and then to nitrate, making nitrogen available to plants. Still others convert nitrate back to nitrogen gas, completing the cycle and returning nitrogen to the atmosphere. All of this happens silently, invisibly, constantly, driven by the metabolism of bacteria too small to see, yet essential to all life. The soil food web is complex beyond human comprehension. Bacteria are eaten by protozoa. Protozoa are eaten by nematodes. Nematodes are eaten by mites and springtails. Each predator doesn't completely destroy its prey population but rather keeps it in check, preventing any one species from dominating. And as organisms eat and are eaten, nutrients cycle through the system, becoming available to plants, which grow and eventually die and decompose, returning their nutrients to the soil to begin the cycle again. Carbon stored in soil represents one of the largest carbon pools on Earth. The carbon in dead leaves, wood, roots, and the bodies of soil organisms gradually becomes incorporated into soil organic matter, where it can remain stored for years, decades, or even centuries. Forest soils store more carbon than the trees above them, and managing forests to maintain and increase soil carbon is one way humans can help address climate change. But this storage happens naturally, automatically, simply through the patient work of decomposers transforming dead matter into soil. Some of the carbon in soil is very old. In the deep layers of forest soil, carbon that was fixed by photosynthesis decades or centuries ago remains, stabilized by chemical bonds with soil minerals or simply protected in spaces too small for decomposers to access. This slow cycling of carbon means that forests are not just holding carbon temporarily but storing it long-term, removing it from the atmosphere for extended periods. The smell of fresh, rich forest soil is actually the smell of a compound called geosmin, produced by a type of bacteria called actinobacteria. This is the earthy smell you notice after rain or when you dig in garden soil, and it's one of the substances humans are most sensitive to. We can detect it at concentrations as low as 5 parts per trillion. Perhaps this sensitivity evolved because the smell indicated fresh water or fertile soil to our ancestors, or perhaps we simply find it pleasant for its own sake. Whatever the reason, the smell of soil is universally recognized as pleasant, calming, grounding. Tree roots penetrate deep into the soil, some reaching dozens of feet down, far below the visible surface. These deep roots access water and minerals unavailable to shallow-rooted plants, and they also transport sugars deep into the soil, feeding deep soil organisms that would otherwise have no energy source. When these roots die, they leave channels that become pathways for water, air, and new roots. A forest's root system is constantly growing, dying, and regrowing, constantly evolving, adapting to changing conditions, seeking resources. The deepest soil organisms live lives we're only beginning to understand. Miles of bacterial life exist in soil deep enough that they've never seen light, never touched the surface world, living on traces of organic matter that filter down from above or on the minerals in the rock itself. These organisms live in slow motion, reproducing perhaps once per century, living for thousands of years, existing in a timescale so different from ours that we struggle to comprehend it. When you stand on forest soil, you're standing on the accumulated life and death of countless organisms, the slow, patient work of millions of years of evolution, a system so complex that we've barely begun to understand it despite decades of study. Soil scientists estimate that we've identified less than 1% of the bacterial species in soil, and far less than that of the fungi. Each handful of soil is a universe of the unknown, life forms yet to be discovered, relationships yet to be understood, mysteries in the literal sense of things we don't yet know. This should bring a sense of humility and wonder. Beneath our feet, invisible, unnoticed, exists a world of such complexity and importance that without it, the surface world we know, the trees, the animals, the flowers, everything, could not exist. Yet it asks nothing from us, requires no recognition, simply continues its work, patient, persistent, essential. As you rest and prepare for sleep, imagine yourself supported by the earth, by the soil beneath your bed, by the rock beneath the soil, by the planet itself. You are held by something ancient, stable, and patient. The Earth has supported life for billions of years and will continue long after your brief span of years has passed. There's a deep peace in recognizing your connection to this Earth, in feeling yourself held by something so much larger and older than yourself. Let the patient work of soil organisms be a metaphor for your own rest. Just as they slowly, steadily, relentlessly break down the complex into the simple, returning all things to the cycle, your body in sleep is slowly, steadily, relentlessly breaking down stress, repairing damage, restoring balance. Trust in this process. Trust in the wisdom of your body, which knows what it needs to do. Simply rest and allow the work to happen naturally in its own time, in its own way. Section 6. Healing properties of the forest. There's a reason humans feel so peaceful in forests, a reason that goes beyond aesthetics or nostalgia. Research has shown that spending time in forests has measurable positive effects on human physical and mental health, effects so significant that in some countries, forest bathing, the practice of mindfully spending time in forests, has been prescribed by doctors as a form of preventative medicine. Understanding these effects can deepen our appreciation of forests and deepen our relaxation as we contemplate them. When you walk through a forest, you're breathing in phytoncides, airborne chemicals released by trees and other plants. These compounds serve the plants in various ways. They protect against insects, fungi, and bacteria, but they also have powerful effects on human physiology. Studies have shown that breathing in phytoncides can increase the number and activity of natural killer cells in the human immune system, cells that play a crucial role in fighting infections and cancer. This immune boost can last for days or even weeks after a forest visit. The specific phytoncides and their concentrations vary by tree species, season, and forest type, but evergreen forests are particularly rich in these compounds. The scent of pine, that sharp, clean, refreshing smell, comes primarily from alpha-pinene and other terpenes, and inhaling these compounds doesn't just smell pleasant. It actually changes your brain chemistry, promoting relaxation and reducing stress hormones. Research in Japan, where forest bathing, or shinrin-yoku, was developed as a formal practice, has documented remarkable effects. People who spend time in forests show decreased levels of cortisol, the primary stress hormone. Their blood pressure drops. Their heart rate variability, a measure of how adaptable the heart is to changing conditions, improves, indicating better cardiovascular health and stress resilience. These effects are not subtle. They're measurable, repeatable, and significant. The effect isn't just physical. Forest bathing has been shown to reduce symptoms of depression and anxiety, improve mood, increase feelings of vitality and energy, and enhance cognitive function. People perform better on attention tests and creativity tasks after spending time in nature. Children with ADHD show reduced symptoms after outdoor activities in green spaces. The evidence is overwhelming. Forests are good for us, profoundly so, in ways we're only beginning to fully understand. Some of this benefit comes from the reduction of mental fatigue. Modern life demands constant directed attention. We must focus on screens, navigate traffic, filter out noise, process information, make decisions. This directed attention is mentally taxing, and after extended use, we experience mental fatigue. Nature, by contrast, engages what researchers call involuntary attention or soft fascination. The patterns of leaves, the movement of branches, the sound of birds, the play of light and shadow. These things are interesting enough to gently hold our attention without requiring effort, allowing the directed attention system to rest and recover. This restoration of attention resources is why a walk in the forest feels so refreshing, even if you're physically tired from the walk. Your mind has been allowed to rest, to wander, to engage with stimuli that are complex enough to be interesting but not so demanding as to be stressful. The natural environment provides exactly the right level of stimulation for mental restoration. The sounds of forests contribute significantly to their calming effect. Natural sounds: wind in the trees, bird song, flowing water, rustling leaves, have been shown to reduce activity in the brain regions associated with external attention and worry, and to increase activity in regions associated with relaxation and meditation. These sounds tend to be complex but patterned, providing enough variety to be interesting but enough predictability to be calming. Consider the sound of wind in pine trees, a sustained AHH that rises and falls as gusts move through the canopy. Or the patter of rain on leaves, each drop creating a tiny percussion note, thousands combining into a gentle white noise that masks other sounds and creates a sonic cocoon. Or bird song, melodic and varied, each species with its own voice, together creating a natural symphony that marks the progression of the day from dawn chorus to evening vespers. Research has found that these natural sounds can mask other environmental noises that would otherwise be annoying or distracting. Traffic noise, construction sounds, the general din of urban life. These can all be mentally stressful, even when we're not consciously aware of them. Natural sounds don't just cover these noises. They actively promote recovery from stress and mental fatigue. Hospital patients whose rooms overlook natural settings recover faster and need less pain medication than patients whose rooms overlook buildings or parking lots. The visual complexity of forests also contributes to their healing properties. Fractal patterns, patterns that repeat at different scales, like the branching of trees, appear throughout nature and have been shown to reduce physiological stress. When you look at a tree, you see the same branching pattern in the trunk dividing into major limbs, in those limbs dividing into branches, in branches dividing into twigs, in twigs bearing leaves with veins that branch in the same pattern. This self-similarity at different scales is inherently pleasing to human perception. Colors in the forest are generally muted compared to urban environments, dominated by greens and browns, with seasonal accents of other colors. Green, in particular, has been shown to have calming effects. It's no coincidence that hospitals often paint walls in soothing greens, or that we describe pleasant outdoor spaces as green spaces. The human eye can distinguish more shades of green than any other color, possibly because our evolutionary history in forests and grasslands made it important to detect subtle variations in vegetation. The quality of light in forests is also unique. The canopy filters sunlight, creating a soft, diffused light quite different from the harsh direct sunlight of open spaces or the artificial light of indoor environments. This filtered light constantly changes as wind moves the leaves, creating an ever-shifting play of light and shadow, bright patches and deep shade, that is visually complex without being overstimulating. Modern research is rediscovering what humans have intuitively known for millennia. Nature heals. Nearly every culture has traditions of seeking out natural settings for healing, meditation, or spiritual renewal. The ancient Greeks had healing temples in groves of trees. Many religious traditions include forest hermitages or meditation retreats in natural settings. Indigenous cultures around the world have healing practices that involve plants, natural settings, and recognition of the interconnection between human health and environmental health. What's remarkable is that we don't need to consciously believe in these healing properties to benefit from them. The effects are physiological, automatic, built into our biology. When you breathe in phytoncides, your immune system responds whether you know about phytoncides or not. When you hear natural sounds, your brain activity shifts toward relaxation whether you're paying attention or not. When you see fractal patterns, your stress response dampens whether you understand fractals or not. This suggests that humans evolved in close contact with natural environments and that our biology is still adapted to those environments. We are, in a very real sense, still forest creatures, and despite our technological advancement, our bodies and brains function best when we have regular contact with the natural world. The stress, anxiety, and various modern ailments we experience may be, in part, symptoms of nature deficit, not enough time in the environments for which we're adapted. The good news is that even imagining or visualizing nature can have beneficial effects. Studies have found that looking at photographs of nature, listening to recordings of natural sounds, or even just imagining yourself in a natural setting can reduce stress and promote relaxation. The effects aren't as strong as actually being in nature, but they're real and measurable. This is why the practice you're engaging in right now, lying comfortably, breathing slowly, imagining and contemplating forests, can genuinely help you relax and prepare for sleep. As you continue to rest here, imagine absorbing the healing properties of the forest. With each breath, imagine breathing in those beneficial phytoncides, those natural compounds that boost your immune system and calm your mind. Imagine your stress hormones lowering, your heart rate slowing, your blood pressure dropping. Imagine your mental fatigue melting away, your attention resources being restored, your mind finding the peace that comes from connection with the natural world. Know that this isn't just imagination. There's real science behind these effects. Your body responds to the thought of nature, to the visualization of peaceful forest scenes, to the remembered or imagined sounds of wind and birds and flowing water. You don't need to be physically present in a forest to begin receiving some of its benefits. Simply directing your attention to forests, contemplating their peaceful presence, can begin to shift your physiology toward relaxation and healing. Let yourself be healed by the forest, even from afar. Let its ancient peace seep into your bones, its patient rhythms slow your racing thoughts, its timeless presence remind you that your worries are temporary, but the healing power of nature is eternal. You are part of nature, and nature's healing extends to you, always without judgment or condition, asking only that you open yourself to receive it. Section 7. The forest through the seasons. Forests move through the year in a rhythm as old as the tilt of Earth's axis, each season bringing its own character, its own beauty, its own particular peace. Understanding this seasonal progression can bring a sense of perspective and acceptance, reminding us that all things change, all things pass, and each phase has its place in the larger pattern. Spring arrives differently in different forests, but it always carries the same message. Renewal, awakening, the return of life after winter's rest. In temperate, deciduous forests, spring begins while the canopy is still bare, allowing sunlight to reach the forest floor. This is when spring ephemeral wildflowers bloom, trilliums, bloodroot, spring beauty, trout lily. These plants have adapted to the brief window between snowmelt and leaf out when abundant light reaches the ground. They grow, flower, produce seeds, and store energy in their roots, completing their entire above-ground life cycle in just a few weeks before the canopy closes and shade returns. The emergence of leaves in spring follows a predictable pattern, beginning with species that leaf out early and ending with those that wait until the danger of late frost has passed. If you could watch time-lapse footage of a forest through spring, you'd see a green wave spreading upward from ground-level plants to shrubs to understory trees, and finally to the canopy, each layer greening in its turn. This gradual greening provides a continuously changing visual feast, each day slightly different from the last. Bird migration brings an influx of sound and color to spring forests. Warblers arrive from their tropical wintering grounds, males singing to establish territories and attract mates. Each species has its own song, its own habitat preferences, its own nesting strategy. The forest that was relatively quiet through winter suddenly fills with sound, dawn and dusk particularly alive with song. For the birds, this is a period of intense activity, establishing territories, finding mates, building nests, laying eggs, raising chicks. But for the observer, there's something peaceful about this seasonal return, this reliability of migration, this assurance that birds have been making this journey for millions of years and will continue long into the future. As spring progresses into summer, the forest reaches peak productivity. The canopy closes, creating deep shade on the forest floor. The frenzy of spring blooms gives way to the steady work of summer, growing, producing, accumulating. Trees add new wood, expanding their trunks and branches. Ferns unfurl their fronds. Mushrooms fruit after rains. Berries ripen, providing food for birds and mammals that will disperse the seeds. Summer in the forest has a stillness to it, particularly in the heat of midday. Many animals rest during the hottest hours, becoming active in morning and evening when temperatures are cooler. The forest provides cooling shade, and the temperature under the canopy might be 10 or 15 degrees cooler than in nearby open areas. This cooling is both physical, shade blocking direct sunlight, and evaporative as trees release water vapor through transpiration. The sounds of summer are distinct from other seasons. Cicadas buzz in waves, their sound rising and falling. Katydids call at night, their rhythmic chirping marking the passage of hours. Crickets chirp from the leaf litter. The frequency of a cricket's chirp is temperature dependent. You can estimate the temperature by counting cricket chirps, and this connection between sound and temperature is part of the intricate responsiveness of the natural world to its conditions. Thunderstorms are common in summer in many forest regions, and a storm passing through a forest is an experience of primal power tempered by the forest's moderating influence. The first sign is often a change in the wind, a stirring of branches that had been still. The air pressure drops, and animals seek shelter. Birds stop singing. Then the wind picks up, bending trees, tossing branches, creating a roar as it rushes through millions of leaves. Rain follows, drumming on the canopy, filtering down through layers of leaves, arriving at the forest floor already slowed and gentled by its journey through the trees. Lightning might strike a tree, sometimes splitting it or even exploding it if the sap superheats and turns to steam faster than the wood can expand. Yet forests are remarkably resilient to lightning. A struck tree might die, but it becomes habitat for cavity-nesting birds, food for insects, and eventually decomposes to enrich the soil. The forest absorbs the damage, incorporates it, continues. Autumn is perhaps the most visibly dramatic season in temperate deciduous forests, though the drama unfolds slowly with dignity. As days shorten and temperatures cool, trees begin shutting down their photosynthetic systems, withdrawing nutrients from leaves to store in roots and trunk for winter. The green chlorophyll breaks down, revealing other pigments that were present all along. Carotenoids that show yellow and orange, and anthocyanins newly produced that show red and purple. The exact colors a tree displays depend on species, weather conditions, soil chemistry, and individual tree health. Sugar maples might turn brilliant orange or scarlet. Oaks turn brown, russet, or burgundy. Birches and poplars turn golden yellow. Dogwoods turn deep red. The result is a tapestry of color that shifts week by week as different species reach their peak and drop their leaves. Leaf fall itself is a gentle process, each leaf releasing when a specialized layer of cells at the base of the leaf stem, the abscission zone, finally separates. The leaf doesn't tear away. It's released, carefully, precisely, when the tree has withdrawn what it needs and sealed the wound that will be left behind. Leaves spiral as they fall, and this spiraling maximizes air resistance, slowing the fall, giving the leaf time to drift away from the tree's base where too many fallen leaves might smother new seedlings. The accumulated leaf litter on the forest floor in autumn can be several inches deep, and walking through it produces a satisfying crunch and rustle. This sound is actually the breaking of dried cell walls, the collapse of structures that were supple and alive just weeks ago but now are brittle and dead. Yet this death is not an ending but a transformation. These leaves will decompose, returning their nutrients to the soil, feeding next year's growth. Animals in autumn are busy preparing for winter. Squirrels cache acorns and nuts. Bears feed voraciously, building fat reserves for hibernation. Birds that migrate are fattening up for their journey, some doubling their body weight in preparation for flights that might cover thousands of miles without rest. There's urgency in these preparations, but it's a natural urgency, instinct-driven, not the anxious rushing of modern human life. Fungi fruit prolifically in autumn, mushrooms appearing seemingly overnight after rains. These fruiting bodies, what we call mushrooms, are just the reproductive structures of much larger organisms living in the soil and dead wood. They release spores by the billions, microscopic particles that will drift on air currents, possibly traveling miles before landing somewhere that might be suitable for germination. Most spores will never germinate, but fungi produce so many that some always find suitable conditions. It's a strategy of abundance, of accepting that most efforts will fail but some will succeed, and that's enough. The shortening days of autumn trigger physiological changes in many organisms. Deer grow thick winter coats. Trees enter dormancy, protecting themselves from freezing by concentrating sugars in their cells, which lowers the freezing point of their sap. Some insects enter diapause, a state of suspended development that allows them to survive winter. Everything is preparing, adapting, responding to the reliable signal of changing day length that tells them winter is coming. Winter in the forest is often thought of as death or emptiness, but this is a misunderstanding. Winter is rest, dormancy, conservation of energy. It's a necessary part of the cycle, a time for systems to reset, for organisms to rest and repair, for the forest to gather strength for the explosive growth of spring. There's a particular peace to a winter forest, especially after snowfall, when sound is muffled and the world seems to hold its breath. Snow accumulates on branches, each twig and branch bearing its burden until the weight becomes too great and the snow slides off in a soft whump. Trees adapted to heavy snow, like spruces and firs, have branches that slope downward, allowing snow to slide off rather than accumulating to branch-breaking weights. Deciduous trees, having dropped their leaves, present less surface area to catch snow, and their bare branches can flex under snow weight, bending but rarely breaking. Animal tracks in snow tell stories for those who can read them. The paired prints of a rabbit, hopping from cover to cover. The precise straight line of a fox, one foot placed almost exactly in front of the other, an efficient walking pattern that conserves energy. The scratch marks where a deer pawed through snow to reach buried vegetation. The wing prints where an owl struck a small mammal, the struggle recorded in disturbed snow. These stories are ephemeral, lasting only until the next snowfall or warm wind erases them. But while they last, they're a record of the forest's hidden life. Winter birds, chickadees, nuthatches, woodpeckers, jays, are often more visible in winter than in other seasons because the bare branches provide less cover. They fluff their feathers to trap air for insulation, making them look round and soft. They search bark crevices for overwintering insects and pupae. They visit seed heads left standing from autumn's plants. Some cache food, like the Clark's nutcracker that buries tens of thousands of pine seeds each autumn in thousands of different locations, relocating them through the winter with remarkable accuracy. The quiet of winter is profound in forests that experience deep cold. There's less wind, as cold air is denser and more stable. There's less animal sound, as many animals are hibernating or less active. Snow absorbs sound. The result is a silence that can feel almost sacred, a hush that invites contemplation and stillness. Standing in a winter forest, you might hear your own heartbeat, your own breath, sounds usually masked by environmental noise. But winter is not completely silent. Ice forming in wood makes tiny ticking sounds as water expands in freezing. Snow sliding off branches makes soft impacts. Deer browse through underbrush, their movements audible in the quiet. Woodpeckers drum on trees, the sound carrying far in the still air. These sounds are precious in winter, notable precisely because they punctuate long periods of quiet. Late winter brings its own magic. The days are noticeably lengthening. The sun, though still low in the sky, has perceptible warmth at midday. Maple sap begins to flow on days when temperatures rise above freezing. The tree is preparing for spring, mobilizing stored sugars to fuel new growth. Some trees, like alders and hazels, bloom in late winter, producing catkins that release pollen on the wind, hoping to reach female flowers before leaves emerge to block the pollen's path. This late winter period is a time of anticipation. Nothing has visibly changed. The trees are still bare. Snow might still be deep on the ground, but the forest is preparing. Buds that were dormant all winter begin to swell imperceptibly. Animals still in hibernation begin to stir, their hibernation lightening. Migratory birds in distant places are beginning their northward journey. Spring is coming, not yet visible but inevitable, as reliable as the Earth's orbit around the sun. And then, almost imperceptibly at first, spring returns. A few birds begin singing. Snow melts from south-facing slopes. The earliest wildflowers push through the leaf litter. And the cycle begins again, as it has for millions of years, as it will for millions more, each season flowing into the next, each with its purpose, its beauty, its place in the pattern. Living through seasons, whether we're conscious of it or not, connects us to these ancient rhythms. Our bodies and minds are affected by seasonal changes, light levels, temperature, the availability of fresh food. In acknowledging and accepting these seasons, in recognizing that we too are part of these cycles, we can find peace in the naturalness of change. Just as the forest doesn't resist winter or rush spring, we can learn to accept the seasons of our own lives, trusting that each has its purpose and that the cycle will continue. As you rest here, imagine yourself moving through your own seasons. There have been springs in your life, times of new beginning, growth, excitement. There have been summers, times of productivity, of being fully engaged and active. There have been autumns, times of harvest, of gathering what you've grown, of preparing for rest. And there have been winters, times of dormancy, of rest, of waiting for the next beginning. All of these are natural. All of these are necessary. None is better or worse than the others. Each serves its purpose in the cycle of a life. Right now, as you prepare for sleep, you're entering your daily winter, a time of rest and restoration. Welcome this rest. Don't resist it. Let yourself enter dormancy, knowing that this rest is not an ending but a preparation for tomorrow's spring, tomorrow's renewal. The seasons turn, both in forests and in lives, and this turning is not something to fear but something to trust, to surrender to flow with rather than against. Section 8. Colors, Light, and Shadows of the Woods. Light in a forest is unlike light anywhere else. The canopy acts as a massive filter, transforming harsh direct sunlight into something softer, gentler, more suitable for the shade-adapted plants and animals below. Understanding how light moves through and transforms in a forest can deepen our appreciation of these peaceful places and the particular quality of serenity they evoke. When sunlight strikes the forest canopy, several things happen simultaneously. Some light is reflected back to the sky, about 10% for most leaves. Some is absorbed by the leaves, powering photosynthesis and warming the leaf, and some passes through, transmitted to the layers below. The light that passes through is selectively filtered. Chlorophyll absorbs red and blue light strongly but allows green light to pass through more readily. This is why forests are bathed in green light, why the shadows under trees have a greenish tinge, why photographs taken in forests often need color correction. This green light has a particular quality that's difficult to describe but universally recognized as peaceful. It's the color of life, of growth, of abundance. It's the color our eyes are most sensitive to. We can distinguish more shades of green than any other color. Perhaps our evolutionary history in forests left us particularly attuned to green, able to detect subtle variations that might indicate fresh growth, ripe fruit, or the presence of water. Light intensity in a forest varies dramatically from top to bottom. At the canopy level, light intensity might be 90 to 100% of full sunlight. At the forest floor in a dense forest, it might be only 1 to 2%. Yet even this dim light is sufficient for some plants: ferns, mosses, shade-tolerant wildflowers. These plants have adapted to low light conditions, often having larger, darker green leaves with more chlorophyll per unit area, maximizing their ability to capture what little light reaches them. Sunflecks, brief patches of direct sunlight that reach the forest floor through gaps in the canopy, are particularly important to understory plants. These sunflecks move across the forest floor as the sun moves across the sky and as branches wave in the wind. A sunfleck might illuminate a particular spot for only a few seconds or minutes, but in that brief time, a shade-adapted plant might accomplish a significant portion of its daily photosynthesis. Plants have evolved to respond rapidly to sunflecks, opening their stomata and increasing their photosynthetic rate within seconds of being illuminated. The movement of sunflecks creates an ever-changing play of light and shadow on the forest floor, a living, breathing pattern that's never quite the same from moment to moment. This dynamic quality is part of what makes forests so visually engaging without being overstimulating. There's constant gentle change, enough to hold attention without requiring focused concentration. Exactly the kind of soft fascination that allows mental rest and restoration. The angle of sunlight changes throughout the day, creating different effects at different times. Morning light, coming from a low angle, creates long shadows and illuminates the eastern sides of trees. This light is often golden or pink, tinted by its passage through more atmosphere than when the sun is directly overhead. It catches on spiderwebs, makes dewdrops sparkle, and creates a sense of freshness and new beginning that's particularly pronounced in forests. Midday light comes from more directly overhead, penetrating deeper into the canopy, creating smaller shadows, illuminating the forest floor more evenly. This is when photosynthesis proceeds most vigorously, when the forest is most productive, though it might also be the quietest time as animals seek shade and rest during the heat of the day. Evening light, like morning light, comes from a low angle, but it has a different quality. It's warmer, more orange and red, as the longer path through the atmosphere filters out more blue light. This is the golden hour, beloved by photographers, when everything seems to glow with warm light. In a forest, evening light creates dramatic contrasts between illuminated and shadowed areas, highlights the western sides of tree trunks, and creates a sense of peace and closure, of the day winding down, of approaching rest. Dusk in the forest is a magical time. As the sun sets and direct sunlight fades, the forest doesn't immediately become dark. Instead, there's a period of soft, diffused light, twilight, when the sky is still bright but the sun is below the horizon. This indirect light is very blue, as blue light scatters in the atmosphere more than other colors. The forest takes on a blue-gray tone, shadows deepen but remain visible, and there's a particular quality of stillness and anticipation. This is when nocturnal animals begin to emerge and diurnal animals settle in to roost or rest. The transition from day to night happens gradually, giving all creatures time to adjust, to find their places, to prepare for the hours ahead. The changing light levels trigger physiological changes in plants and animals, circadian rhythms that govern sleep and waking, that coordinate behavior across species, that maintain the forest's temporal organization. Night in a forest that's far from artificial light sources can be extraordinarily dark. The canopy blocks most starlight and moonlight, and without the sky glow of cities, darkness is nearly absolute. Yet animals adapted to night vision, owls with their enormous eyes, moths with their sensitive antennae, foxes with their keen sense of smell, navigate this darkness with ease. They perceive a world invisible to human senses, hunting, foraging, mating, carrying on their lives in the darkness while most of the forest rests. Moonlight in a forest creates its own special atmosphere. When the moon is full and the sky is clear, enough light filters through the canopy to cast shadows, to allow a human to walk without artificial light, to create a silvery, dreamlike illumination quite unlike any other. Moonlit forests appear in literature and art throughout human culture as places of mystery and magic, perhaps because they occupy a space between day and night, between the known and unknown. Bioluminescence adds another dimension to forest light. Fireflies are the most well-known bioluminescent forest organisms, but they're not alone. Some mushrooms glow with a soft green light, faint but visible in complete darkness. This light comes from a chemical reaction similar to that in fireflies but serving different purposes. In mushrooms, the light might attract insects that will distribute spores, or it might be simply a byproduct of metabolism with no specific function. The phenomenon of foxfire, the glow of bioluminescent fungi growing on decaying wood, has been known throughout human history. In complete darkness, a rotting log covered in the right species of fungus can glow with a ghostly green light, strong enough to read by if your eyes are fully dark adapted. This light was used by soldiers in various wars to read maps without betraying their positions with lanterns. It's a reminder that forests contain wonders we rarely see because we're rarely present in complete darkness to observe them. Seasonal changes in light are as important as daily changes. The angle of the sun changes dramatically through the year in temperate regions. In summer, the sun is high in the sky, and even its low angle at sunrise and sunset is relatively steep. In winter, the sun never gets high, and its low angle means that light penetrates differently through the forest, creating long shadows even at midday. In deciduous forests, the seasonal change in canopy density dramatically affects light levels on the forest floor. Spring, before leaf out, allows abundant light to reach the ground. This is when spring ephemeral wildflowers bloom. Summer, with full leaf coverage, creates deep shade. Autumn, as leaves fall, gradually increases light levels again. Winter, with bare branches, allows much more light through than summer, though the low sun angle and short days mean that total light energy is still less than in summer. The play of light through fog or mist creates some of the forest's most beautiful and peaceful moments. When sunlight strikes fog, it's scattered in all directions, creating visible rays, often called God rays or crepuscular rays, that seem to shine down through the canopy in distinct beams. These beams are visible because the fog or mist makes the light visible, scattering it toward our eyes. Without the fog, the light is there but invisible, revealing one of nature's paradoxes. Sometimes we need obscurity to see clearly. Rainbows are another light phenomenon that appears in forests after rain or near waterfalls where mist is present. The rainbow is caused by sunlight refracting through water droplets, splitting into its component colors. Each color of light has a different wavelength and bends at a slightly different angle, creating the spectrum we see. A rainbow in a forest, framed by green foliage, often with multiple fainter rainbows visible alongside the primary bough, is a sight of particular beauty and wonder. The colors of bark, leaves, flowers, and fruits in forests have been shaped by millions of years of evolution, each color serving purposes we're only beginning to understand. The brown and gray of bark provides camouflage for the tree's vital tissues, making it less visible to herbivores. The bright colors of flowers attract pollinators, each color tuned to the visual sensitivity of particular pollinator species. Blue and purple for bees, red for hummingbirds, white for moths that pollinate at night. The brilliant colors of autumn leaves have been debated by scientists. They clearly result from the breakdown of chlorophyll and the unmasking or production of other pigments. But why? Some researchers suggest the colors are essentially waste products with no adaptive function. Others argue that bright colors might signal to insects that the tree is healthy and well defended, discouraging them from laying eggs on it. Still others suggest that the pigments protect the leaves during the nutrient withdrawal process, allowing the tree to recover more resources before the leaves fall. The truth might involve all of these factors, another example of nature's complexity. As you rest here, imagine the gentle play of light through a forest canopy. Imagine golden morning light slanting through the trees, illuminating mist rising from the forest floor. Imagine the soft green glow of midday under the leaves. Imagine warm evening light creating long shadows and making everything glow. Imagine the silvery mystery of moonlight filtering through branches. Let these images calm your mind, slow your thoughts, prepare you for sleep. Light in a forest changes constantly but gradually, never harsh, never sudden, always filtered and softened by the layers of leaves and branches. It's a gentle light, a peaceful light, a light that invites rest rather than activity. As you sink deeper into relaxation, imagine yourself in that soft forest light, resting on a bed of moss, surrounded by the peaceful glow of filtered sunlight, safe, comfortable, perfectly at peace. Section 9. The Wisdom and Interconnection of Forest Life. Perhaps the deepest peace that forests offer comes from recognizing the profound interconnection of all things within them. A forest is not a collection of individual organisms competing for resources but a community, a network, a living system in which everything is connected to everything else. Understanding these connections can shift our perspective not just on forests but on life itself, revealing a world of cooperation, mutual support, and elegant interdependence. The mycorrhizal network we discussed earlier is just one example of this interconnection. Through fungal threads, trees share resources, carbon, nitrogen, water, not just with their own offspring but with other species. A fir tree and a birch tree, despite being different species, might be connected through fungal networks, sharing resources based on each species' seasonal rhythms. The fir, being evergreen, photosynthesizes year-round, including in winter when the birch has no leaves. The birch, with its large leaves, produces abundant sugars in summer when the fir is shaded by the birch's canopy. Through the fungal network, they can share resources across seasons, each supporting the other when it has abundance and the other has scarcity. This cooperation extends throughout the forest. Nitrogen-fixing plants, like alders and lupins, harbor bacteria in their root nodules that convert atmospheric nitrogen into forms other plants can use. When these nitrogen fixers die and decompose, or simply shed leaves and fine roots, they enrich the soil with nitrogen, benefiting all nearby plants. They're not doing this consciously or altruistically, they're simply following their biology, but the effect is to support the entire community. Predators keep herbivore populations in balance, preventing overgrazing that would damage plant communities. When wolves were removed from Yellowstone National Park, elk populations exploded, and they overgrazed streamside vegetation, which led to erosion, which affected fish populations, which affected bears and other fish eaters, demonstrating that everything truly is connected. When wolves were reintroduced, these cascading effects reversed, a phenomenon ecologists call a trophic cascade, where effects ripple through multiple levels of the food web. Dead trees, standing or fallen, support incredible biodiversity. A standing dead tree, a snag, provides nesting cavities for woodpeckers, which later used by owls, chickadees, nuthatches, flying squirrels, and bats. A fallen log becomes habitat for salamanders, a hunting ground for shrews, a germination site for new trees whose roots can penetrate the soft, rotting wood more easily than the forest floor. The log slowly decomposes, releasing nutrients, creating topography on the forest floor that traps leaves and seeds, eventually becoming part of the soil itself. This use and reuse of resources means nothing is wasted in a forest. Death is not an ending but a transformation. The nutrients locked up in a tree's body for centuries are released through decomposition to fuel new growth. The tree's death creates opportunities. Light gaps where shade-intolerant species can germinate, dead wood where beetles and fungi can live, cavities where birds can nest. What appears to be loss is actually redistribution, rearrangement, continuation in a different form. Birds contribute to forests in ways beyond their obvious roles as pollinators and seed dispersers. Their droppings fertilize the forest floor with nitrogen and phosphorus washed in from distant locations. Corvids, jays, crows, ravens cache seeds and acorns, and like squirrels, they don't retrieve all of them, effectively planting trees. Woodpeckers create cavities used by dozens of other species. Insectivorous birds keep insect populations in check, protecting trees from defoliation while providing a food source for predators like hawks and owls. Even processes that seem destructive contribute to forest health. A forest fire might seem catastrophic, but many forest ecosystems are adapted to periodic fire. Fire clears out dead wood and leaf litter, recycles nutrients into the soil as ash, creates openings where light-demanding species can germinate, and triggers the opening of serotinous pine cones that only release their seeds after exposure to fire's heat. Some species, like jack pine and lodgepole pine, depend on fire to reproduce successfully. Fire is part of the forest cycle, renewal through apparent destruction. Similarly, windstorms that blow down trees create gaps in the canopy, allowing light to reach the forest floor and triggering a new cohort of growth. The fallen trees become nurse logs, their decomposing wood providing nutrients and a raised, moist seedbed for new trees. In old-growth forests, you can often see rows of trees all growing from the same ancient nurse log, their roots straddling what has now become just a linear mound of rich soil. Diseases and insect outbreaks, too, play complex roles. The mountain pine beetle, currently killing millions of acres of pines in western North America, seems purely destructive, but the dead trees will provide decades of habitat for cavity-nesting birds and other animals, and the openings created will allow new forest growth, potentially more diverse and fire-resistant than the dense pine monocultures that preceded them. This doesn't minimize the real losses involved, but it reminds us that nature operates on timescales longer than human lifetimes and in ways more complex than simple good or bad. The forest's interconnection extends to its effect on climate. Forests cool the planet not just by absorbing carbon dioxide, but through their effect on albedo, the reflectivity of Earth's surface. Forests absorb more sunlight than open ground or ice, warming the planet locally, but they also increase cloud formation through transpiration, and clouds reflect sunlight back to space, cooling the planet. The net effect is complex and varies by latitude, season, and forest type, but it's another example of how forests are connected to global systems. Forests affect rainfall patterns sometimes hundreds or thousands of miles away. The Amazon rainforest generates so much water vapor through transpiration that it creates flying rivers in the atmosphere, moisture streams that flow west to east, eventually falling as rain in regions far from the ocean. Deforestation in the Amazon doesn't just affect the local area. It affects rainfall across South America and potentially beyond. Everything is connected, even across vast distances. This interconnection isn't unique to forests. It characterizes all ecosystems. But forests demonstrate it with particular clarity because of their complexity and longevity. A tree that lives 500 years participates in countless relationships during its lifetime, affecting and being affected by thousands of other organisms, contributing to processes that operate at scales from microscopic to continental. Indigenous peoples worldwide have understood this interconnection for millennia, often expressing it through spiritual traditions that recognize forests as sacred, trees as relatives, and the land as something to be lived with rather than exploited. Modern ecology is, in many ways, rediscovering scientifically what traditional cultures knew intuitively: that we are part of nature, not separate from it, and that our well-being is inseparable from the well-being of the natural world. This understanding can be deeply comforting. It means we're not alone, not separate, not isolated individuals struggling in an indifferent universe. We're part of a vast network of life, connected to every other living thing through relationships of stunning complexity. The oxygen you breathe was produced by plants. The water you drink was purified by soil organisms and filtered by forests. The food you eat grew from soil enriched by decomposers. You are literally made of atoms that cycled through countless other organisms before becoming part of you. As you rest here, feel your connection to this vast web of life. Your breath connects you to every photosynthesizing organism on the planet. Your body's water connects you to the global water cycle. Your physical substance, your atoms, connects you to billions of years of cosmic and biological history. You are not a separate thing observing nature from outside. You are nature experiencing itself, a temporary pattern of organized matter and energy that will eventually dissolve and reform into other patterns, just as you were formed from patterns that came before. There's a profound peace in recognizing this connection, this participation in something vastly larger and older than any individual life. Your worries, your stresses, your concerns, these are real and valid, but they're also temporary, small in the context of deep time and vast connection. You are held by systems that have existed for millions of years and will continue for millions more. You are supported by the patient work of countless organisms, from bacteria to trees, all doing what they do, all contributing to the whole. Let this recognition bring you peace. You don't have to do everything yourself. You don't have to understand everything. You don't have to control everything. You can simply be participating in natural patterns, trusting in the systems that support all life, resting in the knowledge that you are part of something infinitely larger and more enduring than your individual self. You are connected, supported, held. You are nature's child, and nature has been caring for its children for billions of years with a patience and wisdom far beyond human comprehension. And now, as we come to the end of this journey through the peaceful world of forests, allow yourself to sink even deeper into relaxation. You've learned about ancient trees standing patient and still for centuries, about underground networks connecting tree to tree through fungal threads, about the gentle breathing of forests, taking in carbon dioxide and giving out oxygen, participating in the breath of the whole planet. You've contemplated the patient cycling of water through forests, falling as rain, filtering through leaves and soil, rising again through trees, returning to the sky to fall again. You've imagined the quiet lives of forest creatures, each playing its role, each adapted to its place, all existing in intricate balance. You've explored the hidden world beneath the forest floor, teeming with billions of organisms breaking down the dead and building the living soil that supports all life above. You've recognized the healing properties of forests, the phytoncides that boost your immune system, the sounds that calm your mind, the sights that restore your attention and reduce your stress. You've moved through the seasons with the forest, recognizing that all things change, all things flow from one state to another, and this changing is natural, necessary, and beautiful. You've seen how light transforms as it moves through the canopy, creating the soft green glow that makes forests such peaceful places. And you've understood, perhaps more deeply than before, that all things are connected, that you are not separate from nature but part of it, that your well-being is connected to the well-being of the whole, that you are held by systems of stunning complexity and ancient wisdom. As you rest here now, completely relaxed, breathing slowly and naturally, imagine yourself as a tree. Your feet are roots, extending deep into the earth, drawing up minerals and water, anchoring you to the planet. Your body is a trunk, strong and stable, home to countless life forms, connected through underground networks to all other life. Your arms are branches, reaching toward the sky, leaves capturing sunlight, participating in the great exchange of breath with the atmosphere. You are patient like a tree, content to grow slowly, one ring at a time, not rushing, not forcing, simply being. You are generous like a tree, giving oxygen freely, providing shelter and food to others, sharing resources through underground networks. You are resilient like a tree, bending in storms but rarely breaking, damaged by fire or lightning but growing new tissue, continuing. You are part of the forest, and the forest is part of you. Its ancient peace is your peace. Its patient rhythms are your rhythms. Its interconnection is your interconnection. You are not alone. You are not separate. You are part of a living planet, held and supported by systems older than imagination. Let yourself rest in this knowledge. Let the peace of forests fill you completely. Let your breath match the slow, steady breathing of the forest. In and out, taking in what you need, releasing what you don't, participating in the eternal exchange that sustains all life. Your body knows how to sleep, just as trees know how to grow. You don't have to try or force or control. Simply allow it to happen. Your consciousness is gently dimming, like the sun setting over a forest, the light gradually fading from gold to blue to darkness, all of it natural, all of it gentle, all of it exactly as it should be. You are safe here. You are peaceful here. You are held by the earth beneath you, covered by the night sky above you, surrounded by the ancient, patient presence of forests, real or imagined, that have provided shelter and peace to living things for hundreds of millions of years. Let go now. Let go of thoughts. Let go of concerns. Let go of awareness itself. Sink into sleep as a leaf falls from a tree, slowly, gently, spiraling down, landing softly on the forest floor, joining the countless others who have made this journey before you, resting, decomposing, transforming, contributing to the endless cycle of death and renewal that is the heartbeat of the forest and the heartbeat of life itself. Sleep now. Rest deeply. The forest will be here when you wake, patient and peaceful, ready to welcome you back. But for now, simply rest, simply be, simply sleep. The forest breathes for you. The earth holds you. The ancient patterns continue. All is well. All has always been well. All will always be well. Sleep peacefully, forest child. Sleep deeply. Sleep well.